Somewhere in what's now the American Midwest, millions once lived off crops you've never heard of. Not because they failed, but because history erased them. And once you understand why, you'll see food systems differently. Here are the forgotten crops that fed millions and then vanished. Goosefoot. Before corn dominated North America, there was another staple. A plant called goosefoot, scientifically known as Chenopodium berlanderi. Today, most Americans would look at it and see a weed. It grows wild along roadsides, in vacant lots, in the margins where nobody thinks to look. But for over 4,000 years, this plant was the foundation of entire societies. Indigenous farmers in what is now Kentucky, Illinois, Missouri, and Tennessee domesticated goosefoot around 1800 BCE. They selectively bred it for larger seeds and thinner seed coats, turning a wild opportunist into a reliable food source, with protein content comparable to quinoa, because it is, in fact, quinoa's closest North American relative. The domesticated version had seeds that germinated faster, yielded more per plant, and processed more easily than its wild ancestors. Archaeologists have found caches of these seeds in rock shelters dating back thousands of years, stored like treasure. Then it vanished. The domesticated subspecies, Chenopodium berlanderi subspecies Jonesianum, is now extinct. Not because it failed. Because when maize arrived from Mexico around 200 BCE, agricultural priorities shifted. And when European colonization devastated indigenous populations, the knowledge of how to grow, harvest, and process goosefoot disappeared with the people who held it. Today, researchers at Washington University in St. Louis are attempting to redomesticate the wild relatives. Their experiments show that when grown alongside another lost crop called erect knotweed, yields match or exceed traditional maize cultivation. The potential was always there. The plant was simply forgotten. If you're finding value in this kind of information, the kind that challenges what you thought you knew, consider subscribing. This channel exists for people who want to understand how the world actually works, not just how it's presented. Amaranth. Amaranth fed the Aztec Empire, not as a minor supplement, as a foundational staple alongside corn and beans. The Aztec name was Huitli, and it was so central to their civilization that 20,000 tons of amaranth grain flowed into the capital of Tenochtitlan annually as tribute from 17 provinces. The grain contains all 9 essential amino acids, making it a complete protein, something corn cannot claim. It grows in poor soil, tolerates drought, and produces prolifically. In terms of pure nutrition per acre, it outperforms most modern staples. So why isn't it everywhere? Because in 1521, when Spanish conquistadors conquered the Aztec Empire, they didn't just take land and gold. They attacked the agricultural foundation of the civilization itself. Amaranth was used in religious ceremonies, mixed with honey to form figures of Aztec deities. To the Spanish, this looked like a direct challenge to Christianity. Fields were burned. Cultivation was banned. Growing amaranth became punishable by having your hands severed. The crop survived only because indigenous farmers hid it in remote mountain villages, passing seeds from generation to generation in secret. For nearly 400 years, one of the most nutritious plants ever domesticated existed in agricultural exile. NASA rediscovered its value in the 1970s. Their researchers identified amaranth's nutrient density as ideal for space travel. Now it's marketed as a superfood in health stores, sold at premium prices to the same culture that nearly erased it from existence. The lesson here isn't just historical, it's economic. When you understand that food systems are shaped by power rather than pure utility, you start seeing opportunities everyone else misses. The MILPA system, modern agriculture, operates on extraction. Take nutrients from the soil, add synthetic fertilizers, repeat until the land is exhausted. 3,500 years ago, Mesoamerican farmers solved this problem with a system called MILPA. You've probably heard it called the Three Sisters: corn, beans, and squash grown together. But calling it that undersells its genius. In a milpa field, corn provides a structural trellis for beans to climb. Beans fix nitrogen from the air into the soil, eliminating the need for fertilizer. Squash spreads across the ground, its broad leaves acting as living mulch that retains moisture and suppresses weeds. Each plant has different nutrient requirements, so they don't compete. Each plant has different pest vulnerabilities, so disease doesn't spread uniformly. Each plant matures at different times, so harvest labor spreads across the season. When researchers measure total system productivity rather than individual crop yields, milpa outperforms monocultures. The system can run indefinitely on the same land without synthetic inputs, something industrial agriculture cannot do. 60 varieties of native corn, 5 varieties of native beans, and 4 varieties of native squash are still cultivated by traditional farmers in Mexico. Every year, they select seeds based on local conditions, continuously adapting their crops to their specific environment. Climate change is now making this adaptation strategy valuable again. When weather becomes unpredictable, diversity becomes survival. Teff seeds are smaller than poppy seeds. About 1 million of them weigh roughly 1 pound. The name comes from the Amharic word meaning lost, because the seeds are so tiny they disappear in harvest. Despite this, teff has fed Ethiopia for at least 6,000 years. Today, over 80 million people depend on it as their primary grain. It grows in conditions that would destroy wheat: drought, waterlogging, poor soil, high altitude. It produces food where other crops cannot survive. The grain is naturally gluten-free and contains more protein, fiber, and iron than most cereals. Ethiopian long-distance runners, who dominate global competition, have traditionally credited their endurance partly to teff-based diets. For most of agricultural history, teff remained confined to the Horn of Africa. The seed was too small for mechanized harvesting, the grain too unfamiliar for international markets. Even Ethiopia banned teff exports for nearly a decade, starting in 2006, fearing that rising international demand would drive domestic prices beyond what local families could afford. That dynamic reveals something important about forgotten crops. Their obscurity often protects them. Once global markets discover value, the same forces that erased other crops, extraction, monoculture, displacement of traditional farmers, begin operating again. Researchers at the Danforth Plant Science Center have now developed shorter, lodging-resistant teff varieties through gene editing. Yields could increase by 20%. The question is whether that development will serve Ethiopian farmers or simply accelerate another cycle of agricultural extraction. The Eastern Agricultural Complex. In 2017, researchers began systematically documenting and attempting to revive Eastern North America's original agricultural system. They call themselves the Lost Crops Network. The crops they study include goosefoot, sumpweed, maygrass, little barley, and erect knotweed. These plants fed indigenous populations for thousands of years before being abandoned when maize took over, and then forgotten entirely after European contact. The domesticated forms are extinct. No written records describe how to grow them. No living farmers remember the techniques. So the researchers are starting over, growing wild relatives and observing which traits respond to cultivation. They've found that when goosefoot and knotweed are planted together, they boost each other's productivity, the same polyculture principle that makes milpa work. Choctaw farmers Amy and Ian Thompson have joined this effort, growing goosefoot at their Nan, Awaya Heritage Farmstead, as part of reviving traditional food systems. Other indigenous communities are requesting seeds from the network's experimental plots. This isn't nostalgia. It's practical response to agricultural vulnerability. Modern crops are optimized for industrial conditions, synthetic inputs, predictable weather, mechanized harvest. When those conditions change, as climate instability guarantees they will, diversity becomes the only insurance that matters. If this perspective on food systems resonates with you, drop a comment below. Tell me which of these crops you'd most want to learn more about. The engagement helps more people find this content. Silphium was worth its weight in gold. This wasn't metaphor. Roman currency stored silphium in the same vaults as precious metals. Julius Caesar himself hoarded nearly 1,500 pounds of its resin in the imperial treasury. The plant grew wild in a narrow strip of land along the North African coast near the Greek colony of Cyrene. Nowhere else. It couldn't be cultivated. Every attempt failed. Whatever symbiotic relationship the plant had with that specific soil and climate couldn't be replicated. Ancient sources described it as a cure for everything from coughs to digestive problems. Modern scholars focus on its documented use as a contraceptive and abortifacient, making it one of the earliest known methods of birth control. Demand exceeded supply, prices rose, harvesting intensified, and by the 1st century CE, according to Pliny the Elder, only a single stalk remained. It was sent to Emperor Nero as a curiosity. This is considered the first documented extinction of a plant species caused by human activity. The identity of silphium remains disputed. Recent research suggests it may have been a species of giant fennel called Ferula drudina, which still exists in Turkey. If true, the extinction story might be more complicated. Perhaps the plant wasn't eliminated entirely, but simply lost its commercial viability as overharvesting degraded quality. Either way, the pattern repeats across history. Valuable plants attract exploitation. Limited supply attracts higher prices. Higher prices attract more exploitation. The cycle continues until the resource collapses. Understanding this pattern is worth more than knowing any individual plant. Sergigna teff. Sergigna teff is not one variety but a mixture. Traditional Ethiopian farmers plant multiple teff varieties together in the same field, creating a living system that adapts to whatever conditions emerge. If drought hits, the drought-tolerant varieties survive. If disease arrives, the resistant varieties carry the harvest. If neither occurs, the highest-yielding varieties dominate. Research conducted in South Wollo Zone found that 53% of surveyed farmers actively maintain these mixed plantings. They ranked the varietal mixture higher than pure improved varieties for drought resistance, disease resistance, and nutritional benefits. This approach contradicts modern agricultural science, which focuses on identifying the single best variety and planting it uniformly. Uniformity allows for standardization, mechanization, efficiency metrics that look good on spreadsheets. But uniformity also concentrates risk. When the Irish potato famine struck in 1845, it devastated the country specifically because Irish farmers had become dependent on a single potato variety. The blight didn't discriminate. Everything died at once. Sergigna teff represents an alternative philosophy, not maximum yield in optimal conditions, but reliable yield across variable conditions, not efficiency metrics but resilience metrics. As climate instability increases, this distinction becomes existential. Maslins. In the remote mountains of Ethiopia, farmers still plant duragna, a term that confused researchers until they realized it referred to wheat and barley planted together as a single crop. This practice, called maslin cultivation, dates back at least 3,000 years and has been documented in at least 27 countries. Across Africa, Europe, and Asia, maslins are not two crops competing in one field. They're one agricultural system where the components interact dynamically. If the year brings conditions favoring wheat, the wheat proportion expands. If conditions favor barley, barley dominates. The farmer plants the same seed mix, but the harvest self-adjusts to whatever reality emerges. Researchers at Cornell University now suggest that maslins offer genuine promise for climate adaptation. Converting even a fraction of global wheat monocultures to wheat-barley mixtures could provide meaningful insurance against weather volatility. The knowledge of how to manage these systems never disappeared in Ethiopia. It persisted because industrial agriculture never fully displaced traditional practice. Women farmers, in particular, have maintained expertise in selecting, processing, and preparing massland harvests. This is what survival looks like when it's not documented in academic journals, knowledge held by people who were never asked to contribute to official agricultural science. Sleeping crops. Indigenous seed keepers don't call them lost crops, they call them sleeping crops. The distinction matters. Lost implies permanent disappearance. Sleeping implies waiting, for conditions to change, for attention to return, for the relationship between humans and plants to resume. Natalie Mueller, an archaeologist at Washington University who has spent years studying Eastern North America's original agricultural system, encountered this framing during conversations with members of the St. Louis Native American Women's Care Circle. They pointed out that calling crops lost perpetuates a colonial myth that indigenous cultures and people are extinct. The wild relatives of these crops still grow. They appear in vacant lots, along roadsides, in the disturbed margins of modern landscapes. What vanished was the relationship, the generations of observation, selection, and accumulated knowledge that transformed wild plants into reliable food sources. That relationship can be rebuilt. It requires attention, time, and the humility to learn from systems that industrial agriculture dismissed as primitive. The patterns apply beyond any specific crop. Every forgotten food represents accumulated wisdom about local conditions, nutritional balance, and sustainable production. Every extinction represents knowledge that cannot be recovered. What this means for your future: 4 crops provide half of human calories. 3 companies control over half of global seed markets. 1 approach, industrial monoculture, dominates agricultural policy, research funding, and land use. This concentration creates vulnerability that most people never consider. When the system works, efficiency looks like wisdom. When the system fails, efficiency looks like fragility. The crops discussed in this video represent alternatives. Not necessarily alternatives you should plant tomorrow, but alternatives that demonstrate what's possible. Agricultural systems can be diverse. Food production can be sustainable. Nutritional needs can be met without dependence on synthetic inputs, global supply chains, or corporate seed catalogs. Knowing this changes how you evaluate risk. Knowing this changes how you interpret food prices, agricultural policy, climate news. Knowing this positions you to recognize opportunities when they emerge. And they will emerge, because concentrated systems eventually face concentrated failures. Pick 1 crop from this video that resonated with you. Research it further. Find out whether anyone in your region is attempting to grow it. Consider whether your own food choices could shift even slightly toward diversity. You don't need to revolutionize agriculture personally. You need to understand enough to recognize when the revolution becomes necessary. If this content helped you think differently about food systems, subscribe. Share this with someone who operates under the assumption that current agricultural arrangements are permanent. Leave a comment telling me which crops you want to explore further. The knowledge exists. The plants exist. The only question is whether enough people pay attention before the next system designed for efficiency encounters conditions it wasn't designed to handle.